Hi, I'm Charlotte McGill.
And I'm Emily Seuss.
We're both sophomores in Aerospace Engineering at NC State University, and we're here today to tell you about the Kepler Space Telescope.
5, 4, 3, 2, engine start, 1, 0, and liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
Kepler was launched on March 6, 2009 from Cape Canaveral on a three-stage Delta II rocket. It was put into Earth-trailing orbit around the Sun with a period of 372.5 days, so that it slowly drifts away from the Earth at a rate of about 15 million kilometers each year. This provides the satellite with a view of the stars mostly unobstructed by the Earth or the Sun, so that it can look at one consistent area of the sky.
The Kepler Space Telescope was designed to study exoplanets, or planets orbiting stars outside our solar system. By observing the tiny brightness decrease as a planet crosses its host star, Kepler can determine the planet's size, density, orbit radius, and many other properties and transmit the data back to NASA.
Kepler's most important component is its photometer. The photometer consists of a Schmidt telescope with a 1.4-meter primary mirror, a focal plane array which captures the light gathered by the telescope, and local electronics which convert the light from the focal array into data. The photometer also has outer shielding and a sunshade to prevent light interference from the sun. At the time of its launch, Kepler's telescope was the biggest ever to be launched beyond Earth orbit.
The telescope's power comes from a 10-square-meter solar array fixed on its outside, which also helps protect it from heating from the sun. The satellite also has a lithium-ion battery to be used during launch and as backup power. The base of the satellite contains most of the electronics and sensors, such as inertial measurement units, star trackers, and thrusters to orient itself in space. It also contains the 4 reaction wheels, which are used to precisely aim the telescope at its target stars.
Kepler was originally focused on one area of the sky in the Cygnus Lyra constellation. Over the course of 3 years, it discovered 135 exoplanets and identified more than 3,500 potential candidates. However, in July of 2012, one of the reaction wheels failed due to an unexpectedly high amount of friction. Kepler only needs 3 reaction wheels to point correctly, but unfortunately yet another wheel failed in January of 2013. This meant that the satellite was completely unable to point itself at its target stars. In August of 2013, NASA officials announced that they were no longer trying to restore full function to the spacecraft.
Fortunately, in 2014, scientists proposed a way to use solar wind to help point the telescope. The new mission, dubbed K2, will now study 10 different star fields instead of 1, and study not only exoplanets but also supernovae, galaxy clusters, and newly forming stars. The K2 mission was approved on May 16, 2014, and will continue for an estimated 2.5 years.
As of December 4, 2015, Kepler has confirmed 1,030 exoplanets and identified almost 4,700 candidates. Kepler has proved itself to be one of the most important scientific tools of the decade and will hopefully continue to search our skies for years to come.